Welcome you to the video lecture for Lecture 9, Unit 2. My name is Jorge, and this is for Statistics 2023. So the objective for this lecture is we're going to go ahead and describe data using measures of variation. And what we're going to talk about is the range, the variance, and standard deviation. And we've already done the range in some of the examples that we've done in class, but we're going to go ahead and go over that again, and then also introduce variance and standard deviation. So the range is simply the highest value minus the lowest value, and the symbol R is used for the range. And so in order to find the range, I just do highest minus lowest. So let's find a range for this particular company. So these are the salaries for the staff of the XYZ manufacturing company, and we're going to go ahead and find a range. So here's the data. So we have the owner, manager, sales rep, workers 1, 2, and 3. I'm going to go ahead and find the range. So the range for the salaries of this particular company is 100,000 minus 15,000, which gives us 85,000, and that's the range. The next thing that we're going to talk about is population variance and standard deviation. So a measurement that will give you a better idea of how the data values differ from the mean is what we call the standard deviation. So if you remember that the formula for the population mean is mu is equal to the summation of x divided by n. So here are the steps to finding the population variance in the standard deviation. The first thing is you got to find the mean. The next thing is you subtract the mean from each data value, and then you square each result. Then you find the sum of the squares. Then you divide the sum by n to get the variance, and then you take the square root of the variance to get the standard deviation. So that sounds like a lot of steps. So I'm going to show you the formulas, and I'm going to show you how to find this using Excel. So the first thing is the population variance. And so the population variance is simply the average of the squares of the distance each value is from the mean. So we find the mean of the data point, and then the variance is just how far it gives you an idea of the distance of each particular data point is from the actual data set mean. And so the symbol for population variance is sigma squared, and the formula is sigma squared is equal to the summation of x minus mu squared divided by n. So each data point minus the mean squared, so that summation squared divided by n. And sigma, that's just the lowercase letter sigma. So the population standard deviation is simply the square root of the variance. So we find the variance, we find the square root of that, and we get the standard deviation. So here we have an example. So we're going to find the variance and the standard deviation for a data set for brand A of paint. And we're going to use Excel to do this. We're not going to do this by hand. So here's the paint information that I have. So what I'm going to do here is I'm just going to go ahead and actually I'm going to do the variance first, and then I'm going to do the standard deviation. You're going to see that it's actually pretty straightforward to find these two values. So equal variance. Now you have to be careful because this is actually a population of paint, so we're going to have to use var.p. And so we just double click it, highlight it, press enter. So our variance is 291.6667. So the standard deviation is just going to be the square root of that. So we're going to do equal SQRT, and there's right there. You double click it. I'm going to highlight this cell because I want the square root of that, and it gives us our standard deviation. So our variance 291.7, and our standard deviation is 17.1. So let's go back to our slides here. So the sample variance is slightly different, and that's why I said when we do it in Excel, you have to make sure that you choose the right one. Otherwise, your final answer is going to be incorrect. And the reason being is because a sample variance, the numerator is the same. We calculate that the same, but we actually divide by n minus 1. And then so the sample standard deviation is a square root of that. So for the population, we divide by n. For the sample, we divide by n minus 1. And the reason being is because it's overstated, if you will, and so it compensates for that overestimation, if you will, the n minus 1. It's also known as degrees of freedom, but it's outside the scope of this course. So The next thing is here we have a sample data set. So we're going to find a sample variance and standard deviation for the amount of European auto sales for a sample of 6 years. So it's a sample. So the data shown is in millions of dollars. So let's go ahead and use Excel to find that. So here are the vehicles. So here's all of the data points for the vehicles. And so what I'm going to do again is I'm going to go ahead and find the variance and the sample variance and the sample standard deviation. So the procedure is the same. So I'm going to press equal. I'm going to start typing VAR, but instead of clicking VAR.P, I'm going to go ahead and click VAR.S. And so I highlight that and then I press enter. So my variance is 1.276, and my standard deviation of course is the same procedure. So equal SQRT, highlight the cell, press enter. So it gives us my variance and my standard deviation for the data set of European auto sales for a sample of 6 years. So the procedure for finding the variance and deviation for group data is similar to that for finding the mean of group data, and it uses the midpoint for each class. So let's go ahead and do that. So the first step is, of course, we make a table. In this table, we actually have one extra column. So we have the class, the frequency, the midpoint. We have the product of the midpoint and frequency, and then we have the product of the midpoint and the midpoint squared, if you will. So the first thing, step 2, is multiply the frequency by the midpoint. We're going to place that in column D. The next thing is we're going to multiply the frequency by the square of the midpoint. I'm going to place that in column E. And then step 4 is we're going to find the sums of the column B, D, and E. So B is N, the sum of D is the summation of the product of F and the midpoint, and then E is the summation of the product of the frequency times the midpoint squared. In step 5, we're going to go ahead and substitute the values that we found into the formula. So S squared is equal to N times the summation of the frequency times the midpoint squared minus the summation of the summation of the product of frequency and the midpoint squared. So these two are slightly different. Here we're squaring the midpoint, here we're squaring the whole summation. And then we're going to divide by N times N minus 1. Don't try to cancel these n's out, okay? You can't do that. And in the standard deviation, it's just the square root of that value. So here we have the miles run per week, right? So we're going to go ahead and find the variance and standard deviation for the frequency distribution here. So here we have all of our columns, right? So we have a class, a frequency, and a midpoint. And so at this point in time, what we're going to do is we're going to go ahead and fill in column D. And we've done that previously, right? And the next thing is we're going to go ahead and do column E. So here we can see that we get 64, 338, and so on. And then what we do is we sum up column B, column D, and column E. So how do we get 64? So we square 8, which is 64, times 1 is 64. We squared 13 times 2 is 338. We square 18 times 3, we get 972, and that's how we get these values. So here's our formula. So we're going to go ahead and here are our other two values. So the three values that we're going to substitute into this formula. So if you notice, our n is 20. So everywhere I see an n, I plug that in. My summation of my frequency times my midpoint is 490. So I'm going to plug it in there in that formula. And then of course I'm going to square that. So here are all my values. So my sample variance then is 67.8, and then the square root of that, which is my sample standard deviation, is 8.3. So the next thing I'm going to talk about is coefficient of variation. Now, a disadvantage of the standard deviation as a comparative measure of variation is that it depends on units of measurement. So that means if I'm talking about millions of dollars, then my standard deviation is in millions of dollars. If I'm talking about feet, my standard deviation is in feet, and so on and so on. So this means that it's difficult to use standard deviation to compare measurements from different populations. So statisticians have defined what we call the coefficient of variation. and this simply expresses the standard deviation as a percentage. So the coefficient of variation, denoted by C var, is the standard deviation divided by the mean, and the result is expressed as a percentage. So for samples, what we do is we take the sample standard deviation divided by x bar times 100. For a population, we take sigma divided by mu times 100. So let's go ahead and do an example. So pages in women's fitness magazine. So the mean number of pages of sample of women's fitness magazines 132 with a variance of 23. The mean number of advertisement of sample of women's fitness magazine is 182 with a variance of 62. Let's go ahead and compare these variations. So here we have square root of 23 divided by 132 times 100 is 3.6 pages, 3.6% in pages, if you will. The other one is 4.3%. The reason we had to do the square root is because they gave us the variance. So the number of advertisements is more variable than the number of pages, since the coefficient is larger for advertisement. So the coefficient of variation can be thought of a measure of the spread of the data relative to the average of the data. The last thing we're going to talk about here is Chebyshevs theorem. Now, the concept of data spread about the mean can be expressed generally for most data distributions, either skewed, symmetric, or any other shape, by using what they call the Chebyshevs theorem. So Chebyshevs theorem states that for any set of data, either population or sample, and for any constant k greater than 1, the proportion of the data that must lie within k standard deviations on either side of the mean is at least 1 minus 1 divided by k squared. So the results of Chebyshevs theorem states that for any set of data, at least 75% of the data will fall in the interval of mu plus or minus 2 sigma. At least 88.9 will fall in the interval of mu plus or minus 3 sigma, and at least 93.8 will fall within mu plus or minus 4 sigma. And we'll talk about that a little bit more later on in the course. So let's use Chebyshevs theorem to figure this out. So the prices of homes. So the mean price of house in a certain neighborhood is $50,000, and the standard deviation is $10,000. So find a price range for which at least 75% of the houses will sell. So that means that the mean is 50,000, standard deviation is 10,000. So what's the range? That means the lowest and the highest that 75% of those houses will most likely sell. So according to Chebyshevs theorem, 75% of data values will fall within 2 standard deviations of the mean. So we're able to use this information. So mu plus or minus 2 times sigma. So mu is 50,000, sigma is 10,000. So 50,000 plus or minus 2 times 10,000 gives us 50,000 plus or minus 20,000. So the range will be between $30,000 and $70,000. So that means that 75% of the houses will sell anywhere between $30,000 and $70,000. Now, when the data values seem to have a normal distribution, we have a theorem that's a little easier than Chebyshevs, and this is what we call the empirical rule. And the empirical rule basically states that 68% of the data will fall within 1 standard deviation of the mean, 95% of data within 2 standard deviations of the mean, and 99.7% of data within 3 standard deviations of the mean. So here's an example. The average salary for graduates with a degree in mathematics is $60,000. If the salaries are normally distributed with a standard deviation of 5,000, then what percentage of the graduates will have a salary between $50,000 and $70,000? So we're going to use mu plus or minus k sigma. Now, since 60,000 minus 50,000 is 10,000, and 70,000 minus 60,000 is 10,000, then that means that 10,000 is equal to k times 5,000, with k being 2, then that gives us the formula of mu plus or minus 2 sigma. So that means that 95% of the graduates will have a salary that's between 50 and 70,000. And again, this is just a quick introduction. We'll talk about all of these concepts more in class. And this is the end of Lecture 9, Unit 2. Thank you.